2, 1, 2, 3.
Okay, welcome to Angel Apparel 369. I'm going to zoom this in right here because we're going to make ourselves a cube, and I haven't done this yet. I just thought might as well do this live and show you because if I can find the drawing I left you with, which was this one. In the video, The Numerical Origins of Cubes, I gave this as kind of a bogus, homework assignment. I said, find the relationships between all the corners, right? Well, I tried to do it too. This was a 4, that was a 2, that was a 6. I had basically taken the 2, 4, 8, 6, and then moved it over there. But then flipped it. See, I put the 2 over there. And I thought that's the best way to do it. And it just wasn't working. Okay, so I started scratching off those numbers, and I changed that to a 2, I changed that to a 4, changed that to an 8, 4, 2, and then the one you can't see here down behind here, I changed that to a 6 to perfectly mirror the 2, 4, 8, 6 on the front. And then I found we got all sorts of mathematical relationships. So here's a hypothesis. Maybe these vibrations are taking place, and of course it's doing times 4 back and forth. So it's totally filling up the space with vibrations. It's doing times 2 in this direction. 2 times 2 is 4. It's doing times 8 in this direction. 2 times 8 is 16. It's doing times 7 in this direction. 7 times 2 is 14. It's doing times 3 in this direction. 2 times 3 is 6. And it's doing times 4 corner to corner. 2 times 4 is 8. 8 times 4 is 32. 4 times 4 is 16. 6 times 4 is 24. See, you got a lot of vibrations going on. So maybe nature's doing this kind of like we do. Maybe it's doing it in slices, and then you get these striations as it gets thicker and thicker. Yeah, like we see in rock layers, especially rock layers with cubical crystalline structure. Okay, and then to tie these rock layers together, look what we have. If this is a 4, we have a 2, 4, and then sideways over here to the 8, to the 6, and then back sideways to the 2 and the 4. We have the 2, 4, 8, 6 going on a diagonal plane. And we've also got the 2, 4 going over here to the 8. 2 times 4 is 8. And then this is going to go over here to the 6. 8 times 2 is 16. Drop the 10. And then come back up here to this corner to the 2. Because 6 times 2 is 12, right? 2 times 2 is 4. So you got this diagonal play going on, and I haven't really given it a lot more thought. But mathematically, it worked out a lot better to make a cube like that. And so that's what I was going to do this morning. I was just trying to figure out, I think I'll use this thing because I'm done playing tic-tac-toe for the morning. So we'll just matter of fact, we might use the X's and the O's. Whoa. Close enough. And then up here somewhere, let's make it so we can, I like this. Let's So what I'm saying yeah is let's see. Yeah, that pen's not very good. Do it this way. That's not very good. Well, and then let's take it over here. And then back here is going to be we'll do it in a dotted line. It's the 6 hidden behind the corner. And so, yeah, well, those pins don't really make it jump, do they? Okay. Yeah. So what I was hoping to do is, we know we got these great relationships between 2, 4, 8, 6, where it's doing the times 3, times 7, times 8, times 2, and times 4 back and forth. And we got that taking place at every single slice. Well, just imagine if there's a whole bunch of slices here, like a 3D printer. Okay, and then as each slice gets thicker, you're also getting a diagonal interplay structurally to 2, 4. Let's draw this out. Let's draw this out just with a parallel orange line, a 2 to the 4. I'm going to take it all the way down here to the front of this, to the 8. Just want you to be able to see it. 6 and back to the 2. This is dotted line and solid line. Okay, like that. See, 2, 4, 8, 6. So now that's given it structure. It's holding those planes together. Let's pick let's use blue. And no. It's already a blue down there. Let's use red. Okay. So it would be from here to here, 2 to 4, right? And then it would be down here to the 8. And then over here to the 6, and I got to go dot, 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 and then back up to the 2, which would be a dot, 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 dot. See, we got 2, 4, 8, 6. Now I want to make this, you can see it better. And it's going. Yeah, kind of like that, And then this is kind of like that. There we go. I think this works a lot better. So I wanted to show that. Something else about the cubes I wanted to show that I didn't discover until this week. I was looking at the original diagram, which I seem to have misplaced completely. The original cube diagram, which is right in front of me. Here it is. Okay, and what I noticed, here, let's get closer to this so you can see better. There we go. Okay, what I noticed, I think I pointed this out on the numerical origins of cubes, the 2, 4, 8, 6, how it's doing all 5 functions, the times 2, the times 8, the times 7, the times 3, and the times 4, corner to corner. 8 times 4 is 32. 2 times 4 is 8. 4 times 4 is 16. 6 times 4 is 24. Okay, but these other cubes are only doing 2 functions. They're not doing the sideways either. Okay, I didn't notice that until a couple days ago. This is doing the times 7 and the times 3, obviously. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 7 times 3 is 21. It's doing the second. These other cubes back here are doing the times 3. 3 times 3 is 9, 9 times 3 is 27. It's doing the times 3 in the counterclockwise direction. See that? It's also doing the times 7 in the clockwise direction. 1 times 7 is 7. 7 times 7 is 49. 9 times 7 is 63. Is that it? 3 times 7 is 21. So it's doing 2 functions. And that's true for all these other squares. And I have an entire list of every single square combination, 4 digits each. I have not examined every single combination yet, but I wanted to ask myself how many 2, 4, 8, 6, because this seems to be the primary. This particular square does more functions than any of these other squares. And in the last digit of the first 60 Fibonacci numbers placed in a circle, we have 1, 2, 3, 4. We have 4 2s. You see that? And every single 2 is doing a 2, 4, 8, 6 cube. A 2, 4, 8, 6 cube. A 2, 4, 8, 6 cube. And a 2, 4, 8, 6 cube. Every single place where a 2 pops up on the Fibonacci sequence, it's also doing this very amazing cube structure. So these are just like things I wanted to update. And this seems to work. Yeah, so I wanted to share that. Okay, and now we're going to move on to the, I think we're ready to look at the amazing star of Solomon. Here at Angel Apparel 369, and thank you for being here. Yeah, these two right here. And this. We're not going to look at this. We're not going to look at this. That's all review. So, that's just amazing stuff. So, we'll get rid of all that. We'll just look at this. Okay. And we have been, the last video was on the 24 wheel angles. Okay, so what we're going to do, and we're back to the 60 wheel, which is the last digit of the first 60 Fibonacci numbers that famously repeats every 60. These last 60 digits famously repeat to infinity. So the 60th digit is ends with a 0, even though it's a big long number. And I don't have my list in front of me, but I've shown it before in other videos how the 61st digit, even though it's going to be like a 10-digit number, it's going to end with a 1. And the 62nd digit is going to end with a 1, and so on and so forth until you get to 120, and then click. This whole sequence is going to start over again until you get to 180, and then click. It'll go until you get to 240, and click. It'll go until you get to 300, and click. But at 300, the last 2 digits start clicking over. I'm serious. It's like a big clock. Okay, and so we're just going to look at these 2 charts, and it's really not real complicated. But they're doing add by patterns. They're doing add by patterns. Add by 2, add by 6, add by 8, add by 4. And you know what's really interesting about this is that's exactly the four numbers, 2, 4, 8, 6. 2, 4, 6, 8. Who do we appreciate? Well, 2, 4, 8, 6 seems to be what's making both squares and perhaps cubes. Okay. So, and here we are. We have stars of Solomon, and what are they doing? They're adding by 2s, 6s, 8s, and 4s. Watch this. I know, it's pretty cool. We're going to go from the orange. Let's just start with the main star. 0 plus 8. And it's going to add together exactly... you have to figure out what it's adding by. Okay, so 0 to 8 is what? It looks like an add by 8. 0 plus 8 equals 8. 8 plus 8 equals 16. And here we have the 6. Okay. 16 plus 8 is 24. And here we have the 4. 24 plus 8 is 32. And here we have the 2. 32 plus 8 is 40. And here we're back to the 0. Right? So yeah, and it works on every single click of the board. So like if you take right here where the orange is on the 1 and then come down here to where the 5 is, because it's, we've clicked it over this way, that looks like an add by 4 pattern, right? So yeah, because 1 plus 4 is 5. 5 plus 4 is, look, here we go, 9. See that? 9 plus 4 is 13. 13 plus 4 is 17. And 17 plus 4 is 21. And we're back to the 1. It works. Now what I'm really curious about right now is, because I don't think I've done it. So let's grab a piece of paper. And let's do this right here. Let's take these numbers. So what did we figure? This was an add by 8 pattern. We had an add by 8 pattern from the 0 to the 8, right? That's an add by 8 pattern. Now we've got an add by 4 pattern. Well, let's just start with the first one. I already know what this is going to be. What I'm wondering is, do we have the 2, 4, 8, 6 pattern that we have experienced in the cube? Okay? Because realize, as this is making cubes, at the same time it's making cubes, it's making these stars of Solomon. And it's making all these pentagonal structures as well. Yeah. So it's doing, and it's all doing, so there's a lot of math going on in all these spaces. So, but we figured this one, 1 to 5, is an add by 4 pattern. Okay, let's take the next one, which would be 1 to 3, which would be an add by 2 pattern. Wait a minute, and the first one, 0 to 8, was an add by 8 pattern. Let's go this way. What is 1 to 7? That's an add by 6 pattern. Here's what we have, you guys. We have the 2, 4, 8, 6, but it's going in the counterclockwise direction. Look at this. That's a 6. So that's, on that theory, will this 9 be an add by 2 pattern? 9 plus 2, even though I'm following down the lines kind of in a clockwise pattern to begin with. 9, this would be an 11, and sure enough, that's an add by 2, because 9 plus 2 would be the 11, right? Right, and 11 plus 2 is going to be this 13 right here. 13 plus 2 is going to be this 15 right here, 5. 15 plus 2 is going to be this 17 right here, and 17 plus 2 is going to be our 19, and we're back to the 9. So this is actually working. So as we're counting in these stars of Solomon, in kind of in a clockwise fashion, and finding these add by patterns, the add by patterns are actually 2, 4, 8, 6, which is a doubling pattern going this way in the counterclockwise direction. Wow. And it will also be an adding pattern going this way. Once you got this all laid out, so this is going to be 6, 8, 4, 2, 6, 8, 4, 2, to infinity, right? Well, look what this is. 6 plus 8 is 14. 8 plus 4 is 12. 4 plus 2 is 6. 2 plus 6 is 8. 6 plus 8 is 14. 8 plus 4 is 12, and on we go. So we have an add by pattern setting up just by setting up a ring of what the star is adding by, whether it's a 2, a 6, an 8, or a 4. Just by doing that, like right now over the top of this, if I scratch those numbers out and I just made that a 6, that's an 8, that's a 4, that's a 2, that's going to be a 6. So let's try it. 6, 2 plus 6, this should be an 8. And there it is. 8 plus 6 should be a 14. And there's your 4 right there. Yeah, it works. So we have this amazing, see? I mean, just look at it. Yeah, that's a beautiful thing. Okay. And again, it's called unicursal because you can do it without taking your finger off. It's like cursive writing, you know. And it's called a pentagram because it has points. If it has sides like this is a pentagon because it has sides. This is a pentagram. And if I did it this way, that's a unicursal pentagram. If I just draw this could be a unicursal pentagon because I can make the entire structure without taking my finger off the paper. And so, what is the pentagon doing? Well, of course, it's doing exactly the same thing. You know, it's got an add by pattern going on. 2 to 4, what is that? That looks like add by 2, so let's do that. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. Yeah. 8 plus 2 is 10. And 10 plus 2 is 12. And this is going to work on every single click of the board. And so I have found we have these same 4 patterns going on. If we go around the outside of this pentagon, it's an add by 2 pattern. But that changes on every click. If you go in a clockwise direction around this pentagram, it's an add by 4 pattern. But again, that is going to change on every click, depending on which one you're on. And we're just dealing with this particular one. And if you reverse the direction and go counterclockwise and follow the unicursal pentagram counterclockwise, and it's an add by 6 pattern. And if you go counterclockwise on the pentagon, it's an add by 8 pattern. We have our 2, 4, 8, and 6 again. And it's going to be in that same pattern. It's going to be, where's my piece of paper? It's going to be in this pattern. It is. So let's test that though. Let's count out, that's every 4, right? And we know that, let's see, 2 to a 6, this is an add by 4 pattern. Okay, so this next one right here should be an add by 2 pattern. This should be an add by 6 pattern. And this should be an add by 8 pattern right here on that little point right there. And here it is down here. 0 plus 8 is 8. Yep, 8 plus 8 is 16, and there it is. 16. 24, and there it is. 24. So they're hard to find. 24 plus 8 is 32, and 32 plus 8 is going to take us back to 40, which is the 0. Yeah, it works. Okay, and then we've already covered the every 7 in this direction, and the every 5 in this direction, the every 9 for 3 revolutions that I call the every 9 icosagon. I don't know, the name might change. This every 5 works no matter where you start. 1, 2, 3, 4, 5. 1 plus 8 is going to be 9. 1, 2, 3, 4, 5, and there it is. 8 plus 9 is going to be 17. 1, 2, 3, 4, 5, and there it is. And then look up the video every 9s and angel primes for this every 9 one, and then I forget which video has the every 7. I think it's in the angel. It has to be in the angel primes. These two are in the same video. Every 9's and angel primes, because 7's a prime number, and every 7 adds together counterclockwise for every 7 digits. 1, 2, 3, 4, 5, 6, 7. 0 to 3 is going to be a 3. 1, 2, 3, 4, 5, 6, 7. 3 to 3 is going to be a 6. 1, 2, 3, 4, 5, 6, 7. 6 and 3 are going to be a 9. 1, 2, 3, 4, 5, 6, 7. There it is. The 6 plus the 9 is going to be 15. 1, 2, 3, 4, 5, 6, 7. There's your 5, and my coffee's burning. Oh well, I'll make some more. I burned my coffee. So, where was I? So that's the every 7. And then the every 3 I wanted to point out, because it looks like the every 3 is a lot like this cube thing, where one cube, the 2, 4, 8, 6 cube, is doing 5 different mathematical vibrations that I've found so far, where the other cubes are only doing 2. Well, that's kind of a similar thing with the every 3. The every 3 only works if you start on one of these even integers. It does not work if you start at the 1. It does not work if you start at the 9. You have to start somewhere along here, which is laid out by the every 9. And I'll get that into that more in the every 9 and angel prime video. Okay, but watch this. 1, 2, 3 is 2. 1, 2, 3 is 2. So 2 and 2 is going to be 4. 1, 2, 3, and there it is. 2 plus 4 is going to be 6. 4 and 6 is back to 10. 6 and 0 is 6. 0 and 6 is 6. 6 and 6 is 12. 6 and 2 is 8. 8 and 2 is 10. And so on and so forth. 8 plus 0 is 8. It works. It works. But it doesn't work if you start at any of these numbers. So it's got a quirk. And that's pretty exciting to me. Because whenever I see a quirk like that, the every 3 only works if you start on the 0. Yeah. But today, I want to read something I found in a book called The Essential Kabbalah, The Heart of Jewish Mysticism by Daniel C. Matt, that has something directly to do with what we're talking about with the numbers and angel numbers. And we might be talking about the same thing the quantum physicists are looking at. They call the seraphim field, which is, from what I found online, they've identified a field that's at sub-Planck scale, which is like below matter, where there's exchanges of information taking place, but they haven't been able to identify what those exchanges of information are. And I'm going to ask the question, could this be those exchanges of information taking place between points within the seraphim field? Could this be like a blueprint of what's happening on a submolecular? Okay? And this is being brought to us strictly by a close examination of the Fibonacci sequence, which we can see. So looking at what we can see, are we actually seeing what we cannot see? Because I'm going to quote some Jewish mystics here. I thought this was fascinating. This is Secrets of Creation, the account of Ezekiel. I'm just going to read from here to there, if you bear with me. The account of Ezekiel's chariot formed one major branch of early Jewish mysticism. The other branch was Ma'aseh Bereshit, the account of creation or cosmology. The most important text concerning these secrets was Sefer Yetzirah, the book of creation, composed apparently in Palestine sometime between the 3rd and 6th centuries. Here we are told how God created the world by means of the 22 letters of the Hebrew alphabet and the 10 Sephiroth, a term that appears for the first time in Hebrew literature. Genesis and Psalms had already indicated that divine speech was the tool of creation. God said, "Let there be light," and there was light. By the word of God the heavens were made, and by the breath of his mouth all their hosts. That's in Genesis 1:1 and in Psalms 33:6. What is new in Sefer Yetzirah is the detailed speculation, and I apologize if I'm not pronouncing any of these words correctly. I'm doing my best. Is a detailed speculation on how God combined the individual letters as well as the idea of the Sephiroth, which in this text are numerical entities, living beings. Can you see that? Embodying the numbers 1 through 10. Ciphers, mystical, metaphysical potencies through which creation unfolds. The notion that numbers are essential to the structure of the cosmos derives from Pythagorean mysticism. Gradually, however, the Sephiroth evolved into something more, becoming the central symbol system of Kabbalah. Wow. Okay. 10,000 Jewish mystics can't be wrong. Be sure to like if you like. And Benny, do you like it? This is my son. He's not with us anymore. But yeah, he likes it. All right. And subscribe, all you scribes. And I'll see you next time. Okay, Sonny Jim out. Stop recording.